Welcome to the lecture series on time value of money, concepts and calculations. Present lecture is on amortization. What is amortization? Amortization is the paying off of debt with a fixed repayment schedule in regular installments over a period of time. Consumers are most likely to encounter amortization with a mortgage or car loan. In business, amortization refers to spreading payments over multiple periods. The term is used for two separate processes: amortization of loans and assets. It also refers to allocating the cost of an intangible asset over a period of time. Amortization happens when you pay off a debt over time with regular equal payments. With each payment, generally monthly payments, a portion of the money goes towards one, the interest cost, what your lender gets paid for the loan, and second, reducing your loan balance as known as paying off the loan principal. At the beginning of the loan, your interest costs are at their highest, especially with long term loans. The majority of each periodic payment is an interest expense and you only pay off a small piece of balance. As time goes on, more and more of each payment goes towards your principal and you pay less in interest each month. Amortized loans are designed so that after a certain amount of time, your last loan payment will completely pay off the loan balance. For example, after exactly 30 years or 360 months payment, you will pay off a 30-year mortgage. Let us take an example through which we will explain this. Construct a amortization schedule for a rupees 1000 10% annual rate loan with 3 equal annual payments. So, P is here 1000, interest rate I is equal to 10%, N is equal to 3 equal annual payments, say A. That means, I am paying A amount each year. From the above equation, the value of A is 1000 into 1.333 into 1 divided by in brackets 1.331 minus 1 is comes out to be rupees 402.12. Basically, this is a equation which has been taken from annuity and the principal is 1000 and we are finding out annuity for 3 years and 1.33 to the power, basically this is 1 plus I to the power n is equal to 1.331 and 0.1 is the I. So, here at t equal to 0 I am sinking 1000 and at the end of first year I am getting 402, that means if I pay 402.11 at the end of first year, then at the end of the second and at the end of the third year, then I can pay a 1000 rupees loan. This is the equation which has been used. P is equal to A in brackets 1 plus I to the power n minus 1 divided by I 1 plus I to the power n, and this equation we have modified because we want the value of A not P. So, A is equal to P into I 1 plus I to the power n divided by in brackets 1 plus I to the power n minus 1. So, the first step is to find out the annuity that we have already found out. Now, in the step 2, find interest charge for year 1. So, interest charge for year 1, if I say INT1 is equal to rupees 1000 into the interest rate, that is 10%, which is 0.1, it comes out to be 100. Now, step 3, find repayment of principal in year 1. So, repayment principal is equal to A minus interest. So, A is my 402.11 minus 100, it comes out to be rupees 302.11. Step 4, find ending balance after 1 year. Ending balance is the beginning balance minus repayment. The beginning balance is 1000. Out of this 1000, the repayment of rupees 302.11 has already been done. So, the end balance becomes rupees 697.89. Now, we have to repeat these steps for year 2 and 3 to complete the amortization table. This illustrates the amortization payments, where the money goes. In the first year, out of this 402.11 which we have paid, this much amount goes to the principal, this much amount goes to the interest, and the second payment, this much amount goes to the for the payment of principal, this much amount goes to the return interest, and in the third year this much amount goes for the payment of principal and this much amount goes for the payment of interest. So, this is how the constant payments are divided per year between the interest and the principal payment. Let us see the derivation of loan payment. There are many type of loan repayment terms. A very common type used for nearly all home mortgages and many business loans call for constant periodic payments for a fixed period. Each payment covers the current interest due and repays some of the remaining principal balance. The total payment is constant, but the principal balance decreases, so that the interest portion of the payment is smaller than the previous one and the principal portion of each payment is larger than the previous one. Amortization tables are widely used for home mortgages, auto loans, business loans and retirement plans. Let us derive it. Let us L is equal to Ij plus Pj. I can write down, where L is the constant payment each period, Ij the jth period interest payment and Pj the jth period principal payment. The index j begins at 1 because payment is made at the end of the period. The symbol I in the equation represents the effective annual interest rate for annual payments or the nominal rate per period R by M for other periods. So, the interest payment I can write down Ij is equal to I into Pj minus 1, where I is the interest rate and Pj minus 1 the principal balance after payment j minus 1. The remaining principal balance after j minus 1 period is Pj minus 1 is equal to P0 minus summation m equal to 1 to j minus 1 Pm, where Pm is the mth principal payment and P0 is the initial amount of the loan. Then based on the equation 1, 2 and 3 we can write down this Pj is equal to L minus Ij equal to L minus Ij I can replace by this quantity 1 into this quantity P0, this is the quantity because this was Ij into Pj minus 1. Now, Pj1 minus can be replaced by this quantity. So, this is replaced here. So, this is equation 4. Now, Pj equal to L minus Ij equal to L minus Ij into this factor, this is equation number 4, I am rewriting it. From equation number 4, P1 is equal to L minus I P0. Now, if I put this j is equal to 1, this is L minus I1 equal to L minus I and this m is equal to 1 to j minus 1. So, it becomes 0. So, it is only P0. So, I into P0. Now, for P2 this comes out to be L minus I in bracket P0 minus P1 is equal to L minus I, then P0 minus P1 is replaced by this quantity, P1 is replaced by this quantity. Okay. So, finally, it comes out to be L 1 plus I minus I into P0 in brackets 1 plus I, and similarly for P3 it becomes L 1 plus I whole square minus I P0 1 plus I whole square, and for general we can write down Pj is equal to L into 1 plus I to the power j minus 1 minus I P0 1 plus I to the power j minus 1, because if I see P3 here, the power of 1 plus I here is 2, that means 3 minus 1. So, when I take j here it will be j minus 1, similarly here also 2, that means 3 minus 1. So, this will be j minus 1. The sum of the all principal payments must equal to the original loan principal, that is payoff of the original loan. Accordingly, summation Pj j1 to n is equal to P0. So, I can write down for this the summation of L 1 plus I to the power j minus 1 from 1 to n minus summation 1 to n I P0 into 1 plus I to the power j minus 1. So, this comes out to be this. L I can take out because this is a constant value, similarly I and P0 I can take out. So, this becomes this. Now, if I solve this for L, so L becomes this P0 in brackets 1 plus I summation 1 to n 1 plus I to the power j minus 1 divided by summation 1 to n 1 plus I j minus 1. So, this gives me the yearly or monthly payment whatsoever be for the loan. Now, let us take an example. Construct a amortization schedule for rupees 10,000, 10% annual interest loan with 3 equal payments in 3 years. So, the component of interest as well as the principal for each payment. Draw your conclusions from the above data. Solution: principal P or PB is equal to 10,000, N is equal to 3 years, I equal to 10%. So, I is equal to I by 100 is 0.1. So, R or the annuity, this is the annuity, R is equal to P into this formula. It basically is a annuity formula, and we are finding out the annuity value which is represented here by R, and in many cases we have represent this by A also. So, is equal to 10,000 into 0.1 into this factor comes out to be 4021.15. So, 3 equal installment of 4021.15 is to be paid off to get 10,000 loan. In the first year, interest component at the end of the first year is 10,000 into 0.1, which comes out to be 1,000. Please note the money was taken at the start of the year. Hence, the amount of principal paid at the end of the first year in the first installment is rupees 4021.15 minus 1000, which is the interest. So, comes out to be rupees 3021.15. So, left out principal amount at the end of the first year is 10,000 minus 3021.15, which comes out to be 6978.85. That means, at the start of the first year the principal was 10,000, but end of the first year when we will pay the annuity it comes out to be 6,978.85. Now, for the second year interest component at the end of the second year is 6978.85 into 01 is comes out to be 697.885. Principal paid at the end of the second year is rupees 4021.15 minus the interest value, that is rupees 697.885 comes out to be rupees 3323.265. So, the remaining principal at the end of the second year is the principal which is left out at the end of the first year, which is 6978.85 minus this values 3323.265. So, it comes out to be 3655.585. That means, this is the principal which is left out at the end of second year. For the third year, interest component at the end of the third year is 3655.585 into 0.1, which comes out to be 365.559. So, amount of principal paid at the end of the third year is 4021.15 minus 365.559. So, amount paid for against principal is 3655.591. So, this is the left out of principal in the third year and hence it is paid. Now, if I draw the amortization table, then I divide into 3 columns, end of the first year, end of the second year, end of the third year. So, installment is the same for all the 3 years, that is 4021.15, 4021.15 and 4021.15. Interest paid is rupees 1000 at the end of the first year. At the end of the second year, the interest drops down to 697.885, and the end of the third year it drops down further to 365.559. Principal paid on the first year is 3021.15. In the end of the second year it rises to 3323.265 and it further rises to 3655.591 at the end of third year. And remaining principal at the end of the first year is 6978.85. At the end of the second year is this becomes 3655.591 and end of the third year the remaining principal becomes 0. That means loan is paid totally. From the above data it is clear that the interest charge is maximum at the end of the first year and minimum at the end of the third year, whereas principal amount paid at the end of the first year is minimum, but at the end of the third year is maximum. Now, take an example where we will calculate the loan. A loan of rupees 50,000 at a nominal interest rate of 15% per year is made for a repayment period of 2 years. Determine the constant payment per period, the interest and principal paid each period and the remaining unpaid principal at the end of each period by using constant end of the month payments. Assume 12 equal length months per year. Now, you will be using the equation which we have derived for the payment. Now, constant end of the period, that is month payment, is equal to L. The principal amount is 50,000, I equal to R by M is 0.15 divided by 12, N is 12 into 2 equals to 24. This is a discrete compounding problem. Now, to compute L, first compute summation 1 to n 1 plus I to the power j minus 1. This comes out to be 27.78808. So, we will see that this is here I have computed this factor. So, first compute this factor and do the summation, and here in the summation it is 27.78808. So, this factor can be very easily computed without the information of other parameters. It only takes into account the value of I and other fixed parameters. So, I can calculate this very easily, 27.78808. Now, where P0 is the principal amount is 50,000, I equal to R by M is 0.15 by 12, N equal to 24. Hence, L is equal to 50,000 plus, I am using this formula, this 50,000 in brackets 1 plus I, this is 0.15 into summation this. This I had already calculated. So, it is 27.7808 divided by 12, because this I will be divided by 12. So, the 12 is here, I divided by 12, because here R by I equal to R by M, this is 0.15 divided by 12, and then whole divided by this value which is 27.78808, divided by 27.7800. So, the value of L, the monthly payment, comes out to be rupees 2424.33. At the end of the first month, the interest will be 50,000 into 0.15 divided by 12, which comes out to be 625. So, principal paid at the end of the first month is this L value subtracted by this interest, this comes out to 1799.33. So, this is the principal amount which will be paid at the end of first month. So, remaining amount of principal at the end of first month is 50,000 minus this value, which comes out to be 48,200.67. Similarly, interest charge at the end of the second month will be interest will be charged on this amount because this is the left out principal. So, 48200.67 into this is the rate 0.15 divided by 12 because this is the monthly rate of interest comes out to be rupees 602.51. Principal paid at the end of the second month is the value of the L, that is payment, this is each month minus this interest comes out to be 1821.82. So, remaining amount of principal at the second month is, this is the remaining amount at the end of the first month minus this 1821.82 comes out to be 46378.85. Now, we see that we fill up this table, this is the this parameter we have computed here, this is 1 and this is 1.0125. This is the constant payment which is being made 2424.33. The interest paid in the first month, this we have already calculated, principal paid for the month, this we have already calculated, and remaining principal we have already calculated. For the month 2 also these values we have already calculated. So, once this is calculated we can fill up these values in this table, and then we can sum up. This is 27.88 and this value is 58,183.92. That means through constant payment for a principal of 50,000 I will be paying 58,183.92. This is the interest paid, total interest paid is 8,183.99 and the total principal is 50,000 rupees, and this shows you the remaining principal. Thank you.